In this video, we will be discussing about product of the last k numbers. Design an algorithm that accepts a stream of integers and retrieves the product of last k integers of the stream. Implement the product of numbers class. Product of number initializes the object with an empty stream. Add int num appends the integer num to the stream. Get product int k returns the product of last k numbers in the current list. You can assume that always the current list has at least k numbers. The test cases are generated so that at any time the product of any contiguous sequence of numbers will fit into a single 32-bit integer without overflowing. So what they are saying is that we are given the product of numbers class in which we have two functions. One is the add function and one is the get product function, and we need to implement these two functions. Now they are saying that we are maintaining an integer stream, and whenever the add function is called, then this particular number is appended into the integer stream. And whenever the get product is called, then that means we need to return the product of last two numbers from the integer stream, right? So if we look over here, when add 3 is called, so in our integer stream 3 is added. So let us suppose that I am maintaining a vector or an array, and inside that I am pending whatever is the number that I am getting, right? Let's make this as 1 now, because the 0 case we will discuss later. Okay, so now this is a stream and now 1 is being added into it, so 1 will be added here. Then 2 is being added, so it will be 3 1 2. Then 5 is added, so it will be 3 1 2 5. Then 4 is added, so it will be 3 1 2 5 4, right? Now they are calling the get product 2. Basically this means that we need to return the product of last two integers from this vector, right? So what we can simply do is that we can start iterating from the last index, right? And we can get the product of last two numbers, which will be 20. So here we will return a 20, right? Then last three numbers, so it will be 2 5 4, so it will be 20 into 2 40, so this will be the answer. Then last four, so last four will be this one, again it will be 40 only, right? Then they are asking us to add an 8 into the stream, so the stream will look like 3 1 2 5 4 8, and then the product of last two numbers, which is 4 and 8, will be 32. So this is how we can do. Now here we are maintaining an array or a vector, and when we are adding a particular number into it, so that will take constant time. So that is okay. But when we need to find out the product of last k integers, at that time what are we doing? We are iterating from the end up to k integers, right? Now this k might go to the starting. Basically it can be equal to n, right? So in worst case, this particular function would run n time with a complexity of order of n, right? So let's optimize this. Now how to optimize this? So see, basically we have some integers. From those integers, we always want that what is the product of last k numbers, right? We want the product of these last k integers from the array. Now this k is not fixed, right? Now see, we have solved many problems using the concept of prefix sum, right? In prefix sum, what do we do is that we again have some set of integers and we need to find out the sum of a subarray, right? So basically, if let us suppose that my array is like 1, 2, 3, 4. Now they can ask me the sum of any range from this, right? If I give the indices, it will be 0, 1, 2, 3. So they can ask me what is the sum of elements within this range or this range or this range. So for that, what do we do is that we maintain a prefix sum array, right? And how that prefix sum array is built, that first element is initialized as is. Then in the second element, what do we do is that whatever we have here, in this we add this particular number and then we add it over here. So here we'll add a 3 by adding these two. 3 plus 3 will be 6 and 6 plus 4 will be 10. So this is how we create the prefix sum array. And if I give the indices, it will be 0, 1, 2, 3. Now if someone asks me that what is the sum of last two elements in this array, then what I will do, I want to find the sum of these two elements, right? So what we do is we take this index value and we go two indices towards the left, which is this particular index, right? So we subtract this and this. Basically we do 10 minus 3, which gives us 7, which is the sum of last two elements. If we see 3 plus 4 is 7. That is how we do. So a similar approach we can follow in this particular case also. The only difference is that here we need to find the product instead of the sum, right? So instead of doing sum over here, we will do the product. And when we need to find the answer, then instead of doing subtraction, we will do division. We will divide it, right? So let's solve it again. Let's come here. So first of all, whenever your class is initialized, what we will do is that in our vector, we will initialize it with 1, and we will also maintain a variable which will tell us that what is the size of our input string, right? Now this one is only to handle the out of bound case, right? Because we need to go one index towards the left. Only that is the reason that we are appending 1 over here. Otherwise, the size of our integer stream is actually 0. Right. So whenever we are initializing our class, we will initialize our vector with a 1 and size with 0. Right. So now when add 3 is called, the vector will look like 1 comma 3. Basically this 3, how did it come? 3 into 1. Right. And here the size will be 1 now. Then 1 is added. So it will be 1, 3, and then 1 is not going to be added as is. We are maintaining the prefix product array over here. So we will do 1 into 3. So it will give us 3 only. And the size will be 2. Then next is adding 2. So here we will do 2 into 3, that is 6. And the size will become 3 now. Then we need to append 5. So it will be 5 into 6, that is 30. And the size will become 4 now. Then we are adding a 4 over here. So it will be 1, 3, 3, 6, 30. And then 30 will be multiplied by 4. So it will be 120. And the size will become 5 now. Now when they are asking us to get the product of last two elements, what we can simply do is that if let us suppose that our vector is p, we can simply do p of size divided by p of size minus k, right? So right now here k is 2 and size is 5. So we will do p of 5 divided by p of 5 minus 2, that is 3. If I give the indices 0, 1, 2, 3, 4, 5. So at 5 we have 120 divided by 3 we have 6. So it will be 20, right? So for this the answer will be 20. Then for last 3, these elements, so it will be 120 divided by 3. So it will be 40. And then last 4 elements, which will be these. So 120 divided by 3 again. So it will be 40 again, right? And then we are appending 8. So it will be 1, 3, 3, 6, 30, 120. And then 120 into 8 will be 960, right? And then we need to get the product of last two elements, which will be 960 divided by 30. So it will be 32. That is how we can solve this. Now if you see in the add function, we are doing the multiplication of this element with the last element in the vector, and then we are appending it, right? So this is taking constant time. And in the get product function, what are we simply doing? We are applying this particular formula, which is also constant. So now both of our functions have become constant, right? But we don't end here. If you remember, here was a 0 earlier, right? Let me put that back because that is going to change it. Let me remove all of this again. So if you see, when I am adding a 0 over here, what I will do, I will multiply it with the last element and then I will append it, right? 0, whenever it is multiplied with anything, it will give me a 0 only, right? So basically a 0 will be appended here. When I will move next, again 0 into 2 will give me a 0. Then when I will add 5, again 0 into 5 will give me a 0. So now if you see, it will always be 0. Right, I will never be able to get the answer. Here it is asking to get the product of last two elements, which should ideally be 20. But in our case, it will be 0, which is wrong. So we will have to handle this particular case also. And how we can handle that? So let's see what are we going to do. So what I will do over here is that whenever I am adding a 0, I will re-initialize my vector and the size. When we were initializing it, we were pushing a simple 1 into the vector and making the size as 0. So whenever we are encountering a 0, whenever we are adding a 0, I will make the vector like this and I will reinitialize the size to 0. How this is going to help us, that we will understand once we go through all these examples. So now they want to add a 2, so it will be 1 comma 2, size will become 1. Then 5, so 1, 2, and then 2 into 5, 10. So size will be 2. Then they want to add a 4, so 4 into 10 will be 40, and here the size will become 3 now. Now they are asking us to get the product of last two elements. So we'll apply the same formula. So it will be 40 divided by 2, that is 20. Then they want last 3. So of these 3, so it will be 40 divided by 1, that is 40 only. But now if you see, they are asking us to find the product of last four elements, right? So of all these elements, but we do not have anything here. If I apply this formula, then what is the size? Size is 3 divided by 3 minus what is k? 4. If you see, this index is -1, but -1 index does not exist, right? But how are we able to get a negative index? Because in the question it is mentioned that whenever the get product function is called, it is guaranteed that there will always be these many integers existing in your integer stream. So how are we getting a negative index over here? This is because here we had reinitialized our vector. We lost whatever we had added before this 0, right? Now this means that if I am trying to find the product of these many numbers and I don't have an index existing over here, so then that means here we would have a 0. That is the reason we are getting a negative index, right? And if there is a 0 within this range, then that means the product of all those numbers will be 0, right? So we can simply return a 0 over here, right? Basically, what we can check is that if in any case our k becomes greater than the size, then we will simply return a 0. If you see here, the size was 3, k is 4. So k became greater than the size. So in that case, we will return a 0, because that is implying that it is including the numbers from this range which we dropped. And why we dropped? Because of 0, right? So that is the catchy point in the solution. And then they are asking us to add it. So it will be 1, 2, 10, 40, and then 40 into 8 will be 320. And then the product of last two elements will be 320 divided by 10, which will be 32. So this is how we are going to solve this problem. Now let's look at the code. So before looking at the code, I just wanted to make a small update that I will be taking a break for some time due to some reason, but I will be back soon. So here, first of all, let's create a vector for storing the prefix products. Let's name it p, and then we will take an integer variable size, which will be initialized with 0. Now, whenever we are initializing our class, what we will do, we will make p as 1. Basically, in the vector, we will only have a 1, and we will initialize our size to 0, right? Now, whenever the add function is called, we have two conditions over here. If the num is a 0, in that case we need to do a different thing. If it is not 0, then some different thing, right? So we'll put a check that if num is 0, then what do we want to do? We need to reinitialize our vector with a 1, right? And the size with a 0. Else, if the number is not a 0, then what do we want is that we want to multiply it with the last element present in the vector and then push it, right? So we will do p dot push back whatever is present at the last index into this particular number, and then we will increment the size by 1. This is how we can implement the add function. Then in the get product function, we want to check that if in any case the k is greater than the size, in that case we need to return a 0. Otherwise you will return whatever is present at the index size divided by whatever is present at the index size minus k. So this is what we are going to do. Let's run this. Now here add function is also taking constant time and get product function is also taking constant time, right? So for n operations, if you have n operations, your time complexity will be order of n. And if we talk about the space complexity, so we have taken a vector over here in which we are storing the prefix product of all the elements of our integer stream, right? So basically we are storing n elements over here. So the space complexity will be order of n. So let's submit this now. So it got accepted. Thank you so much for watching. Please like the video and subscribe our channel.